Team, it's Mr. Z, and today we're going to look at standard form of quadratic functions. Let's dive in. All right, so essentially, standard form, we all know it, we all love it, is essentially f of x when we have a coefficient in front of x squared plus bx plus c. This is what we know and love. This is our bread and butter, standard form. An example of a function like this would be 3x squared minus 27x plus 42. The reason this is called standard form is because this is the simplified version of a function. So let's keep this in mind. It is always the simplified version of a quadratic. Remember, what is the degree of this polynomial? It is degree 2, because the highest exponent is 2, which means that it's going to have 2 solutions. Let's go ahead and look to see what else we can see from just the quadratic form. So I'm going to go ahead and look at this first leading coefficient. It's a 3x squared. Now this is going to play a large value in the direction of this quadratic. Remember, quadratics can take two forms. They can be concave up or they can be concave down. When this value in front, when the a value, when a is 3, it is going to be concave up. So when it is a positive value. Notice when it is concave up, there's a smallest point in the center that directly cuts it into two symmetric pieces. This is called the minimum. The vertex here is a minimum because it is the lowest point on this quadratic. Vice versa, when a is equal to a negative value, the vertex is going to be a little different. The vertex is going to be the center of this quadratic, and it is going to be the maximum because this is the largest point in the entire quadratic. So let's go ahead and continue. Now, what else can I say about this guy? Well, I've already determined that the graph of f of x is going to look like this. The only other thing I can easily get is I can assert that because c is 42, I can say that the y-intercept of this graph is going to occur at 0, 42. So how did I know that? Well, let's go ahead and dive in. The y-intercept is when the graph is touching the y-axis. It can be here or it can be here. Notice this coordinate would have to be something along the lines 0, comma, we can say positive 2. And this coordinate would be something along the lines of 0, negative 2. Notice what's similar in both of these cases. My x value of both of these coordinates are 0. Hence, notice how the x is fixed into 0. This is just part of the definition. So to find the y-intercept, let y x equals 0, which means I'm going to plug it in for x in my above quadratic. So notice here how this 0 replaced the spot of the x. It's reading when x value is 0, what is going to be the output? So I'm going to replace my variables with a different color for emphasis that I am substituting it in When I replace a letter with a number, I put it in parentheses. Now let me go ahead and evaluate it. I'm going to get f of 0. When x is 0, my answer is going to be, well, 3 squared is going to be still 3 times 0 minus 27 times 0 plus 42. The product of both of these are just going to be 0. So I'm going to be left with 0 minus 0 plus 42. Notice what this reads. F of 0 equals 42 is the verbal way of saying when x is 0, the output is 42, aka y is 42. Notice how I can algebraically get the point 042. So this is everything I can get from the standard form of a function. Essentially, from the simplified version of a quadratic, I can get two things. The first being I can determine the concavity, whether it is concave up or concave down. The second conclusion I can draw is finding out that the y-intercept, and the y-intercept is always going to be the c value. So just looking at it in standard form, I know it's always going to resemble this form. All right, that was a deep dive into quadratics, looking at standard form. There's a lot of information to be gained, but notice how I was able to create all of this visualization of what this looks like without plugging it into Desmos. That's it for now. Ciao.